Hi, welcome back to Mrs. Snow's Virtual Science Classroom. This will be the acceleration due to gravity video. Saturday, I'm at school. This is hour 4. I have no makeup on, but I do have a Panera iced coffee, so that's important. Anyway, hopefully you've already watched the video or you understand how to use all these equations for straight line motion. And that's what this is going to be about too, straight line motion, but a specific kind, and that's free fall, or when the only thing acting on the object is gravity, the force of gravity. We pretend there's no air, nothing's spinning. This is the beginning parts of physics. So we can use all of these equations as long as we realize that the acceleration, because of gravity, is negative 9.8 meters per second squared. And you can write that on your equation sheet. You can use that on the test. You can't use this if it's a car going down a road, or a ball rolling across the ground, or a cat running down the street. You can only use this if something is in free fall. Something's gone off a cliff. You're throwing something up in the air. That's the only time that you can use it. So some of the rules. Let's say you do drop something off a cliff. Every time you drop something, the initial velocity is 0 when you drop something. So if you drop something off a cliff, the initial velocity is 0. In the problem, they are not going to tell you that the acceleration due to gravity is negative 9.80 meters per second squared. You have to know that. And that's only at sea level. It changes with elevation. So you have to write that down too, though. Then they're going to ask you different things. How tall is this cliff? Okay. That's your displacement, and if you're dropping something, displacement is going to be negative. They ask you for how tall it is. That's a distance question, but that's delta x. Or they might ask you, how fast is it going when it hits the ground? You might think, well, it's going to stop. Yeah, it is going to stop, but it will have a final velocity. That's why when you drop things on your feet, it hurts. So there will be a final velocity. So you can use those original equations for any of that. And if you drop something, that's not too bad. The problems aren't too hard. VI will cancel out like they have other times when we say we start from rest. But sometimes that isn't what happens. Sometimes, I need an eraser. Sometimes we throw things. So if we throw something straight down, the initial velocity is not going to be 0. It's not going to be 0. Also, we can throw things up into the air. Acceleration is still negative 9.8 meters per second squared, but if I throw this marker up in the air, it's going to leave my hand with a certain initial velocity. And it's going to be positive at first. And then gravity is going to slow it down until it's at its maximum height. And up here at the top, the final velocity at the top before it comes back down is 0. So we can figure out a lot of things. You can figure out the amount of time it takes to get to the top of its flight. And if you double that, that'll be the total time it's in the air, because, another concept, the time up is equal to the time down. Time up is equal to time down. That's going to be important. So you can break the path of the flight of the pen in half. And so you say it leaves my hand with a velocity. Here's the other thing. It's going to hit my hand with that same velocity, just in a different direction, same magnitude. So that's how you're going to solve these problems for the acceleration due to gravity. Keep all of these things in mind, and hopefully this helped a little bit.